Question A asks us to describe two features of the graph above that identify HA as a weak acid. Now, as you can see, I transferred the graph from the problem onto the screen. So, at first, you can see that the pH of the solution is not at 1, it is in fact at 3. So it is a weaker acid. And the pH at equivalence point is above 7. It's around at 9, which is basic. And if this was a strong acid and a strong base, it would be at 7. And problem B asks us to describe one method by which the value of the acid dissociation constant for HA can be determined using the graph above. And one method we could use to find the Ka value is by using the Henderson-Hasselbalch equation. And that equation is pH is equal to pKa plus the log of A minus over HA. And at 1/2 equivalence point, pH is equal to pKa, since the concentrations of A minus and HA are the same. And if A minus and HA are the same number and you divide them, you'll get 1. And the log of 1 is 0, so really the equation will be just pH is equal to pKa. And problem C asks us to sketch the titration curve that would result if 25 milliliters of 0.1 molarity HCl were used instead of 0.1 molarity HA. So the difference between HA and HCl is HCl is a strong acid and HA is a weak acid. And they both have the same volume. So the equivalence point will both occur at 25 milliliters. So there are two key differences in the graph. One is that the initial pH of the solution will be at 1 because HCl is a strong acid. And secondly, the equivalence point will be at 7 since this is a strong base and strong acid titration. And problem D asks us to find the volume of the base that must be added to each the equivalence point. So I got 2.5 millimoles by multiplying the 25 milliliters and the 0.1 molarity to get millimoles. And the 2.5 millimoles is equal to 2.5 millimoles of OH minus. And then if you divide that molarity by, and if you divide that 2.5 by the molarity of the NaOH solution, you will get 14 milliliters. And secondly, it asks us to explain why the pH at the equivalence point for this titration is slightly higher than the pH at the equivalence point in the titration using 0.10 NaOH. So in the 0.1 molarity NaOH solution, the total volume at equivalence point is 50 milliliters. And you can see that from here. So it's milliliters of NaOH added, it's at 25, but there was initially 25 milliliters of the HA in it, so 25 plus 25 is equal to 50. So there's 50 in the HA and NaOH. And in the 0.2 molarity NaOH solution, the total volume at the equivalence point is 38 milliliters. And I got this number by adding the volume value that was given to us in the problem, which was 25 milliliters. And I added that by the volume we calculated in the first problem. And the small volume in the 0.2 NaOH means that A minus is larger compared to the A minus at the equivalence point with the 0.1 molarity NaOH, therefore resulting in a slightly higher pH.